Clock starts now. Okay, so this is an extension of what we did yesterday. A chord is visible right in front of you. AB is a chord. And this area is a segment area. You call this area a segment. If there's a center given, let's call the center C. Center of the circle is C. The radius is R. The angle made at the center is theta. So it's this area, which is area of segment. This area is inside the sector, but outside the triangle. So something is inside the sector. The area of sector is theta over 360 into pi r squared. That's the area of a sector, guys. Similarly, अगर हम कहें area of triangle, उसमें से निकाल दें, तो area of triangle is half r into sine theta. That's the value of the area of the triangle. Half r into sine theta. So this formula that you see in front of you is what we would term as the area of the segment. So remember yesterday, guys, we said that the area of any triangle can be found by the formula half a into b into sine theta. And if there is a triangle with sides, an equilateral triangle with equal sides, and the angle is 60, we said this could be done by half into x into sine 60. Or we said you could memorize the area of a triangle as under root 3x squared over 4. Over here, we're saying that the segment is part of a circle. It's inside a circle. It's inside the sector of the circle, but outside the triangle. The triangle's area, take that away from the sector. The pizza slice, take this triangle away from it. You get the area of the segment. This formula would hold true when the angle is in degrees, guys. This is going to be true when the angle is in degrees. Now, if the angle happens to be in not degrees, but rather radians, then there's another formula. The formula is r squared over 2 bracket theta minus sine theta. That's the formula that you would use if the angle is in radians. Radian angle. You could use this formula. There's a change of mode and all that. I'll go over this. Some of you know it, some of you don't. So I'll go over that. Especially Fatma and Manur have not seen this. Murtaza also has not worked with radian calculator mode. I don't know if Ayat has done it or not. Ayat, have you found sine of 60 in a calculator, and have you gone on to find sine of pi by 3 in a calculator? Remember?
Yes, sir.
You have. All right. So he knows how to deal with this. Sine of 60. Remind yourself that pi by 3 is 60 degrees represented in radians. So the answer needs to be the same. The answer the calculator needs to return is under root 3 over 2. But when you feed the calculator pi by 3, the calculator is innocent. It does not know what are you feeding it. It thinks that you're feeding it 3.142 divided by 3, a small angle, 1 degree angle. Instead, you are feeding it radians. So you've got to change the mode of your calculator to radians. So you change the mode, rad mode, and then you find this out, and it also would then return you under root 3 over 2. I'll log in from my other PC. Yes, Casio calculator, the calculator that you would have on your, yeah. So if you think कि हमारे पास calculator होगा Desmos में, so Desmos में you're doing sine 60. It is programmed. So Desmos Skies is programmed. So I did pi over 6. Pi over 3. So it gives me 0.8666. It does not give me the third form, the square root form. It's square root 3 over 2. Square root 3 whole upon 2. This is sine pi by 3. So you need the other calculator. Your Desmos is not good for these numbers, because if options are given, it'll just waste your time. So how do you program your calculator in Desmos to change its radians? Here you see radian degree, radian degree, radian degree. So if I change this to degrees, see how sine 60 changes? It's now 0.866. But sine pi by 3 becomes something else because I fed it degrees and it does not know that pi by 3. So you see that? You see the stark difference, how the values now shift. So first it was radian mode, pi by 3 per 0.866 I on root 3 over 2. Then I shifted to degrees, 60 per 0.866 I, which is under root 3 over 2. Yeah. So we will look at the kind of questions that appear. So questions ki abhi to practice hi nahi ki, guys. So I'm feeding you formulas right now. Don't worry. When we get to questions, I know you guys are eager to find out what the questions look like. The questions will vary in their type. So let's, so I won't waste a lot of your time now. So here it is. Have a look. This is, all right, let me just get rid of this. Actually, so if they say the centers of the circles lie on the circumference of the other. Okay? The centers of the circles lie on the circumference. What is the shaded area? So what is the shaded area? If find the shaded area if the radius of the circles or radii or if the area of one circle is 100 pi. 100 pi. Okay. Not 10 pi, 100 pi. All right. So 100 pi is the area. This thing. All right. 100 pi. Ignore my pi, please. It's 100 pi. So you are required to find the area of the shaded region. Now, guys, you need to understand that if you were to draw a vertical from here till the bottom, the centers are lying on the circumference. So if this is center A, this is center B, and let's call this D and E. So this area, if you're able to find this area out, you can double it to find the area of the entire shaded region. This area, you need to recognize that this area is a segment. How is it a segment? It's if you notice, it's inside the sector, but outside the triangle, where DE is a chord. So if you're able to find this area out, the segment area, what was the formula? Formula was simple. The formula was theta over 360 into pi r square area of sector minus half r into r, which is r square sine theta. That was going to give you the area of the segment. And if you have the area of the segment, all you need to do is double that, because it's both sides. So there are two segments. Now comes the idea, where's the angle? We don't have the angle. For that, you need to manipulate the angle yourself. How do you do that? You realize that from A to B, and from B to D, and from D to A, these will be just, what would they be? They'd be radiuses, radii. They're radii. Because A is the center of the circle and B is also the center of the circle. AB is a radius. A to D is also the radius, because center of the circle to the circumference. Since AB is the same thing, B to D is also the radius. If all lengths are equal, then this is 60 degrees. If that is 60, angle at the bottom is also 60. So you know that the angle is 120. 120 over 360 into pi 10 squared. Where did we get 10 from? We got 10 from pi r squared, minus half into 10 squared sine of 120. So our next chapter, after we do all the geometry, will be trigonometry. Trigonometry is up next. After we've done enough practice, we can't do all kinds of geometry questions. We can do some, not all. Okay, so getting back to some practice. The practice will be from various topics. Question number 3. Please do it. Please do question 3. Please do 3 and then 6. I am pausing the recording. Do remind me कि मैंने unpause or record